Okay, hello and welcome everyone. So in this video, I'm going to do a walkthrough of 5 exercises that are relevant for the second exam in my Principles of Micro course. Basically, the questions are going to correspond to topics of comparative advantage, absolute advantage, gains from trade, not necessarily with the production possibilities frontier. Also labor markets, labor demand, labor supply. Let me go ahead and show each of those 5 questions here first, and then without the solution. So here's the first one. Like if you want, I don't know if you want to stop the video and then, kind of quiz yourself. So there's the first. Here's the second. Here's the third. Oh, also positive and positive externalities question. And there's like a short answer essay, mathematical essay, free response question that I'll do as well. All right. And then here's the last multiple choice question. Here's the free response question. So I'm asking you to draw a collection of graphs to talk about these circumstances, and then to be able to interpret the graphs. Okay, so without further ado, let me go and solve these questions, solve these exercises. And I'll do each in turn. All right, so here's the first one. Suppose there's 2 people in the economy, Morgan and Robert. Suppose there's 2 goods that could be produced, fish and pineapple. Suppose Morgan and Robert work 200 hours per week or per month. It takes Morgan 4 hours to produce a fish, 5 hours to produce a pineapple. It takes Robert 10 hours to produce a fish and 2 hours to produce a pineapple. When working on their own without the possibility of specialization and trade, Morgan produces 20 pineapples per month. Robert also produces 20 pineapples per month. Each uses the rest of the month to produce as much fish as possible. If they're allowed to specialize in trade, they'd collectively end up with exactly the same number of pineapples as before. How many more fish are they able to collectively produce? Okay, so for the structure of this question, what it's basically asking you to do is you've definitely got to figure out who's got a comparative advantage in fish and in pineapple, but we've got this additional restriction. So we've got a starting point. The status quo is each are producing 20 pineapples per month for a total of 40 pineapples per month between them. That tells us that afterwards, if they specialize and trade, we still want to do this in a way where they're still getting at least 40 pineapples per month. So whoever is going to specialize in producing fish is just going to make fish. Whoever is going to do pineapples, though, is going to make 40 pineapples and then allocate the rest of their time to fish. The reason why is we said we want exactly the number of pineapples as they had before. So we only want 40 pineapples. So whoever's specializing in pineapples isn't going to make as many pineapples as they can. They're just going to make 40. All right, how many more fish would they collectively be able to produce? All right, so here's the starting point. I'm going to look at Morgan, I'm going to look at Robert. Morgan can produce 50 fish or 40 pineapple in this time, right? So we know this because Morgan has 200 hours. It takes 4 hours to produce a fish, so 200 divided by 4 is 50 fish. Or, maximally, Morgan could get 200 hours divided by 5 hours per pineapple, a total of 40 pineapples, right? The next thing that I do is I compute the opportunity cost. The marginal cost of a fish for Morgan is 4/5 pineapple, and the marginal cost of a pineapple for Morgan is 5/4 fish. Now, actually, the way that I like doing this, I'm going to have to move this around a little bit, sorry. The way that I like doing this is writing out our opportunity cost principle, our or what statement. And so I say Morgan could produce 50 fish or 40 pineapples. And then I get this to a statement about like 1 for however many. So I want to get a statement about how many fish are sacrificed when making a pineapple and how many pineapples are sacrificed when making a fish. Right? All right, so if I divide the numbers here by 50, this will give me the opportunity cost of pineapples for producing 1 fish, right? 50 over 50 is 1, 40 over 50 is 4/5, which tells us that the statement that Morgan could produce 50 fish or 40 pineapples is equivalent to saying that Morgan could produce 1 fish or 4/5 pineapples. So because these have to be reciprocals, then we know the opportunity cost of producing 1 pineapple is 5/4 fish. Or we could go back to our statement and we could say, let's divide the numbers by 40 now. So 50 over 40, or 40 over 40, is another way to represent the same relationship, 5/4 fish or 1 pineapple. So that's where that came from, right down here. Now, originally what was happening was Morgan was producing 20 pineapple, and we weren't told how many fish that Morgan was producing, but we need to calculate that because we need to know how many more fish they're going to get after they specialize, right? So, okay, so we want to figure out how much time these 20 pineapple cost Morgan. Well, there's 200 hours total, 4 hours per fish, 5 hours per pineapple. We got 20 pineapple, which tells us those 20 pineapple cost Morgan 100 hours. And therefore, Morgan only had 100 hours left over with which to make fish, but that allowed Morgan to produce 25 fish, because 100 divided by 4 is 25. Okay, what about Robert? Robert's going to give us 20 fish and 100 pineapple, because in those 200 hours, Robert could produce, well, 200 divided by 10, or our 20 fish, or 200 divided by 2, our 100 pineapple. By similar logic as I did for Morgan, I could say, okay, Robert could produce 20 fish or 100 pineapple, or Robert could produce 1 fish or 100 divided by 20, or 5 pineapple, right? So the opportunity cost of 1 fish is 5 pineapple for Robert. The opportunity cost of 1 pineapple was 1/5 of a fish for Robert, because these have to be reciprocals. Just staring at this before we go any further, since we've got it, right? Who has the lower opportunity cost of producing fish? Oh, well, producing 1 fish costs 4/5 pineapple for Morgan, but it costs 5 pineapple for Robert. Morgan has the lower opportunity cost. Morgan has the comparative advantage in producing fish. Therefore, Robert has the comparative advantage in producing pineapple. But, okay, going back to the problem, we had to figure out if Robert's going to produce 20 pineapples and use the rest of the time for fish, how many fish do we get? Those 20 pineapples cost Robert only 40 hours. Robert, therefore, has 160 hours remaining with which to make fish and can give us 16 fish. So our status quo, our starting point, is 40 pineapple, 20 from each character, and then 25 fish from Morgan, 16 fish from Robert, for a total of 41 fish. Now, if they're going to specialize according to comparative advantage, those 40 pineapples are coming from Robert, right? And the fish will get 50 fish from Morgan. But Robert's only going to make exactly 40 pineapples and then is going to use the rest of the time for making fish. So we have to determine if we get the exact same amount of pineapples as before, that's 40, and if Robert's doing that, how much time does that cost Robert? Oh, it's going to cost Robert 80 hours, meaning Robert's going to have 120 hours remaining. And at a rate of 10 hours per fish, Robert's going to give us 12 fish, to which we'll add to Morgan's 50 fish, right? So Robert's giving us 40 pineapple and 12 fish with those 200 hours. Morgan's giving us 50 fish and 0 pineapple. Total, we're going to end up with 12 plus 50 or 62 fish, which is greater than the 25 plus 16, 41 fish available previously. So that is an increase of 21 fish. The correct answer is C, 21 fish, right? C, 21 fish is correct. All right, so the next one. The table below shows the output per worker for wine and for smartphones in France and the US. If France has a comparative advantage in wine and absolute advantage in smartphones, what are the possible values for X and Y? So this is just a table showing like what's the maximal output when each uses all of its resources for one of these things or the other. We've redacted France's productivity of wine and the US productivity of smartphones, but we're told France has to have a comparative advantage in wine and an absolute advantage in smartphones. All right, so to have an absolute advantage in smartphones, that's telling us that France has to be producing more smartphones than the US, so Y has to be something smaller than 200. Otherwise, the US has the absolute advantage in smartphones, right? So by definition of absolute advantage, being the one who can produce the most or the most efficient producer, right? Y has to be smaller than 200. So we know we're looking for one of these with Y smaller than 200. We can already cross off B, and we can cross off D. All right, but what about for a comparative advantage? For comparative advantage, this has to be the case that France is giving up less to produce wine in terms of foregone smartphones than the US. All right, we already said y has to be smaller than 200. Let's just say for the sake of argument, it's like it is 200, right? Just for that the break point. So then it would be 100 wine or 200 smartphones, or 1 wine for 2 smartphones, which means for each wine, France has to be giving up fewer than 2 smartphones. For that to happen, we need x to be larger than 100. Right? So x has to be larger than 100 for comparative advantage, so that if I then divide through both sides by 200, or now if I divide both sides by whatever we're setting as x, we want that to be bigger than 2, which would be like the break point for what the US is getting, on the assumption that y is like smaller than 200, right? So the idea is, for comparative advantage, it must be the case that France is giving up less smartphones for each wine than the US is. The way that we guarantee that is we make x bigger than 100. Okay. Yep, so answer A is correct. Which of the following are true of positive consumption externalities? So the way that I approach these is I look at what's the structure of the answer, like what's the information, how's it organized. This concerns social benefit, marginal private benefit, market quantity, and then socially optimal quantity. How are those things related? Well, with a positive externality, the issue is that there is some additional external benefit that spills over to bystanders. And so marginal private benefit plus that additional spillover externality gets us to the marginal social benefit. So the marginal social benefit has to be greater than the marginal private benefit in the case of a positive externality. So that's going to help us narrow down the answers quite a bit. The other thing is, the problem with externalities is that in the case of positive externality, the market quantity, what the market delivers from comparing private benefit to private cost, is going to be smaller than the socially optimal amount, which would take into consideration the additional spillover benefits. Right? So the market quantity is going to be smaller than the socially efficient quantity. This happens with answer C. Marginal social benefit exceeds marginal private benefit. Right? There's this additional external benefit that's greater than the benefit captured by the individual, by definition a positive externality. And the market equilibrium quantity is less than the socially optimal quantity. That's also like kind of a consequence of the positive externality structure. Right? So answer C is correct. All right. 4. What would happen to the equilibrium hourly wage and equilibrium quantity in a particular industry if the following events occurred? Advances in the production technology have increased the marginal productivity of workers in that industry, and government increases the amount of unemployment benefits available to workers. All right, well, the first one, advances in production technology have increased marginal productivity of workers. That's going to increase the marginal revenue product by virtue of increasing marginal productivity, which is going to increase labor demand. Right, so we're going to get a rightward shift of the labor demand curve. Other things equal, when we get a rightward shift of a demand curve, we compete up the price, in this case the wage, and then the quantity rises as well. So as marginal product rises, demand rises, so wage and quantity is going to rise. And the government increases the amount of unemployment benefits available to workers. This is going to reduce labor supply, because people are going to be able to greater tolerate being unemployed. And so this income support increase is going to cause labor supply to fall. With a leftward shift of the supply curve, labor becomes more scarce, right? So the wage rises, and then the quantity is going to fall. So what we're looking for as a result is a situation where, for sure, we know what the wage is going to rise, but then the quantity could rise or could fall. So I'm going to look for an answer that's going to tell us overall wage rises and then quantity is unknown. That happens with answer A. Equilibrium quantity rises for certain. Impact on equilibrium quantity employed is unknown. All right. And then the last multiple choice. Suppose we observe a decrease in hourly wage and a decrease in employment of fast food workers. Which of the following explain this outcome? Let me address those in a second. First, this is the guidance in terms of what we're looking for. A decrease in hourly wage, so we need the price to fall, and a decrease in employment, so we need the quantity to fall. For price to fall and for quantity to fall, we're looking for the labor demand to decrease. Labor supply could increase, labor supply could decrease, but as long as labor demand decreasing is the overwhelming effect, then wage and quantity will fall. Okay, so let's look at each of these. People decide to do more home cooking, which reduces the demand for meals from fast food restaurants. That's going to shift labor demand to the left, right? Less demand for meals, therefore, since labor is a derived demand, there'll be less demand for workers producing those meals, right? So this will give us a leftward shift of labor demand. That's correct. That's going to give us, what, a fall in wages and a fall in quantity. That's this one right here. This has to be part of any correct answer. Unhelpful, right? Because this first one shows up in all of these. All right, what about number 2? Automated ordering systems become less expensive to implement, and the substitution effect dominates the scale effect. All right, so this is a decrease in the price of capital, which means it's going to be easier on average for firms to substitute capital for labor. If the substitution effect dominates the scale effect, what this is telling us, remember, we can, without too much confusion, we can think of the scale effect as like workers being a complement for machines. Substitution effect, this is like workers replaced by machines, right? So if the substitution effect dominates the scale effect, on average, people are losing their jobs, right? That's a decrease in labor demand. When labor demand falls, wage falls, and then quantity falls. All right, the new PlayStation and Xbox hit the gaming consoles hit the market, caused a significant increase in the value placed on leisure. Well, that means fewer people are going to work at all possible wages. That's a leftward shift of labor supply, right? So the wage is going to rise, quantity is going to fall. Well, that's a problem because we need the wage to fall, right? And so number 3 can't be part of any correct answer. And so let's see, this already might help us narrow it down. We need 1 and 2. So that leaves C as a candidate answer. And then C can't be any part, or 3 can't be part of any right answer, so it can't be E. So, okay, we actually still do need to look at 4, because it shows up here. Federal government increases minimum wage from $7.25 per hour to $15 per hour. Well, that's a problem, because what we were told here is that we need the hourly wage to fall, but this is telling us the hourly wage is rising, right? So 4 can't be right either. So the best answer is going to be C, 1 and 2 only. And I don't know what I'm thinking back, like, what was my comment here? I don't know if I can replicate that logic that made me write that, but either way, what this is doing is the wage is rising and the quantity is falling. In this case, right? At the higher wage, there's going to be less employment, right? But the thing that really is discounting 4 and making that not right is the wage is rising, but here we want the wage to fall, right? Decrease in hourly wage. Okay, so yeah, answer C is correct. All right, so now for the longer form question, be sure your responses model clear economic reasoning and address each of the following. As a result of the pandemic, demand for products purchased from Amazon rose. At the same time, workers' costs rose as they subjected themselves to potential health hazard, working outside their homes. Ultimately, wages at Amazon rose to at least $15 per hour. This is just me making an observation about the world, and now I'm asking you to show the graphs to model the situation. How can we ascertain whether demand or supply had a stronger impact on the rising wage? All right, you actually kind of be careful here because I presented information for a demand shift and a supply shift in kind of 2 forms. This right here is a statement about demand in the product market, right? This right here is a statement about the supply in the labor market. Remember, labor is a derived demand, so if there's an increase in demand in the product market, the price rises. The output price that the workers are helping to produce is relevant for the marginal revenue product, right? Marginal revenue product was the product of you just multiplying price and then marginal product, right? And that was one and the same with the labor demand curve. Remember, the theory of demand is the theory of marginal benefit. And in this case, the theory of labor demand is the theory of marginal revenue product. So if marginal revenue product rises, then labor demand rises, right? So this is going to give us a rightward shift of the demand curve in the product market and therefore a rightward shift of demand in the labor market. This is going to give us a leftward shift of supply in the labor market. Both are going to be a recipe for rising wages, which could explain the $15 per hour. How do we know whether the demand effect or the supply effect had a bigger impact? Well, we'll look and see what happened to the quantity. Were more people hired by Amazon before or after, right? If more people were hired during than before, then we'd say, oh, it must have been a demand increase story. But if fewer people were hired, then we're saying, oh, it must be that workers are scarce, and that's why the wage is rising, right? So, okay, so here are those pictures. This is from before, sorry. So this was the product market. This is the increase in demand for products produced by Amazon. This should be a P for price on the vertical. This should be a Q for quantity on the horizontal. This is going to cause an increase in the equilibrium price in the product market, which is part of the PMPL, which is our marginal revenue product. Remember, marginal revenue product is just price times the marginal product, in this case of labor, right? It's marginal product is how much additional output you get from hiring one additional worker. You multiply that by the price of that output in its own market to determine the value of the output produced by an additional worker. Right? So if there's an increase in the value produced by a worker, there's going to be an increase in labor demand. Right? So we get an increase in wage, increase in quantity. What about the effect? What about the supply effect? Well, here we're getting a leftward shift of the labor supply curve. That's going to tend towards an increase in price and a decrease in quantity. And we don't know which picture, this top one or the bottom one, is more descriptive, right? Because it leaves open the possibility that, both curves are moving at the same time. This is actually like the morning-evening method. So when you have two effects, maybe suppose the demand effect happens in the morning, the supply effect happens in the evening, and then at the end of the day, what's happened? Well, wage has risen for sure, and quantity could rise or fall. How do we know exactly which one had the stronger effect on the market? Well, we could look at the effect on the quantity, right? And so if we see actually the number of jobs offered by Amazon rose, we'd say, oh, it must have been a labor demand increase story. But if we see fewer people employed by Amazon, then we must say, oh, it's got to be a decrease in labor supply story responsible for the increase in price. The last thing here was, this was from one of the multiple choice questions. I was observing the fact that we had a decrease in labor demand, and so the wage would fall, the quantity would fall, and then I said, well, we know for sure labor demand is falling. Labor supply could rise or fall as long as labor demand was the dominant effect. Here's the graphs reinforcing what I meant, right? So if I have here a leftward shift of demand in both cases, in this case, this is coupled with a leftward shift of supply. Wage falls, quantity falls. However, in this case, this decrease in demand is coupled with a rightward shift of labor supply. Still, wage falls, quantity falls. Why? Well, the decrease in demand was so much larger than whatever was the change in supply that it swamped out that effect. In this case, the decrease in labor demand, or whatever, was the dominant effect. Okay, anyway, so I hope these exercises were helpful. I'll go ahead and conclude here. Hope you enjoyed the video, and good luck on upcoming exams.